The year was 1896. Again, in search of knowledge, the net was cast into the sea of the unknown, and like in our fable, a catch was made, an accidental catch. The discovery was made by Henri Becquerel, a French scientist.
Today I discovered something very strange. I happened to leave a piece of uranium on a wrapped photographic plate in a dark drawer. When I developed the plate, I found that it was fogged. Apparently, the uranium had exposed it, even in the darkness and through the wrapping. This uranium, it seems to possess some mysterious activity and give off some type of radiation all by itself. C'est extraordinaire.
Becquerel had discovered radioactivity. Pierre and Marie Curie, two other French scientists, were greatly intrigued by this strange phenomenon. While seeking the source of the radiations from uranium, they discovered a new element which gave off even stronger rays.
Look, our new element. How radiant it is. It even glows in the dark. We should call it radium.
Radium turned out to be a mysterious source of energy. This remarkable element would go on radiating like an endlessly flowing spring. This was against all laws of science known at that time. How could this tiny mass contain so much energy? This mystery shook the very foundations of science. It was finally understood in 1905 when Albert Einstein discovered an important new law. His theory showed that every mass contains a tremendous amount of energy.
E stands for energy, M for mass, and c squared is the speed of light multiplied by itself. Now, c squared is a very great number, and so, if multiplied by even a small mass, the result will be a very great amount of energy.
This is a cold scientific explanation, but its deep meaning can be easily understood through our fable. Einstein, like the fisherman, found that a mighty force was contained in a small vessel. Radium constantly releases tiny bits of its energy through radiation, a little bit every second. And there is so much energy that this activity can go on for thousands of years. These rays were actually tiny fragments of atoms breaking apart. No longer could the atom be considered the smallest particle in nature. Evidently, the atom was not an indestructible little ball after all. But then, what was it? The first clue to this question came from Lord Ernest Rutherford of England. The year was 1911.
Today, I used the fast-flying fragments of radium as tools to probe into the atom. I placed a small sample of radium inside a solid lead block. The lead absorbed all the rays except those that were allowed to escape through a small opening in the block. One might say it was a sort of atomic gun. To make the ray bullets visible, I used a fluorescent screen. For a target, I chose a very thin leaf of gold. But to my surprise, the bullets from my atomic gun passed right through the gold leaf as though it wasn't there. It was like like shooting at a ghost. This was truly amazing because the gold leaf was a solid wall, 2,000 atoms thick. So the atom can't be as solid as we always thought. Then, unexpectedly, one out of thousands of bullets ricocheted, striking something solid. I can only conclude, then, the atom is mostly empty space, like a cloud or shell. But occasionally I hit something solid. It must be very small, a tiny particle in the center. I shall call it the nucleus of the atom.
With Rutherford's discovery of the nucleus, scientists began to understand how nature builds her atoms. The shell of the atom appears solid, just as a fast-whirling fan seems solid. Actually, the shell is composed of a whirling swarm of tiny electrical particles called electrons. They circle around the nucleus like planets around the sun. So the atom is like a tiny solar system. But scientists are ever curious. Like the fisherman who examined the vessel he had hauled ashore, they began to probe the atomic nucleus for its secrets. They found that it was composed of small particles electrically charged. They called them protons, which means primary particles. Later, to the great surprise of science, other strange particles were discovered in the nucleus. They had no electrical charge. They were neutral, and so they were called neutrons. At last, the mystery of the atom structure was solved. How amazing nature is. Think of it. There are countless solar systems of atomic suns and planets in everything. There's a whole universe in the tip of a pencil. Even in this tiny pencil dot, there are billions of times more atoms than there are people on our Earth. There are many kinds of atoms. It's interesting to see how they differ in the various elements. It's a fascinating study in numbers. Let's start with number 1. The simplest atom in nature. 1 proton and 1 electron give us the element hydrogen, a very light gas. Nature always keeps an electrical balance in her atoms. So, if the nucleus has 2 protons, it will also have 2 circling electrons. This makes an atom of helium. There are also neutrons in the nucleus that add to its weight. And so, by simple addition, nature builds the atoms of all her elements. 6 protons and 6 electrons and some neutrons for carbon. (16 and 16) for sulfur. 26 iron. 47 silver. 79 gold. 92 uranium the famous radioactive element.